Hello students, welcome to my channel Learning is Fun by NGB. I hope you are liking all my videos uh, that I've already uploaded in my channel. Uh, these days I'm focusing on AI because AI is a very important part of computer science and as well as in our daily life. So in my previous videos I've already given introduction to AI, domains of AI, and yes, I have given an explanatory video on the first domain, that is data science. And so today I'll be focusing in my today's video I'll be focusing on the next domain of AI, that is computer vision. So let us understand what is computer vision. So, what is computer vision? What do you mean by computer vision? I hope you all have some kind of idea about computer vision or the human vision that we possess. Okay, we see things through our eyes, we can then analyze them, we can interpret it. That's our brain does. And then accordingly, we come to a conclusion or decision. We try to identify the patterns, or the, etc. etc. Similarly, computer vision, here in this part, the machines are given the ability to see and understand and make sense of the visual information in the same way like we do, the human does. Okay? So, computer vision is a field of study and technology in AI that lets the machine see and understand the visual information like a human does. And this machine has the ability to process the visual data and get uh, useful information from those visual data like images, videos, and even real time video streaming. So, using this digital image and deep learning models, computers can accurately identify, process, and analyze those visual data. And then they will react or extract meaningful insights based on what they have seen. So, here is a pictorial representation. You can see the difference of the human vision and the computer vision. Input is given to the sensing device. Sensing device will forward the input to the interpreting device, and finally the output will be that there is a bowl, there's oranges, there bananas. Will be divided into the data will be divided into different categories. Now let's come to the process of computer vision. So these are the various steps that computer vision, the process of computer vision involves. This is the following steps. First is the image acquisition. Here the uh, process is to collect the image, collect the visual information from images of videos. Also, the information that can be collected from the cameras, then sensors or stored image. So once this data has been collected, okay, then the pre-processing is done, where in the pre-processing involves that the data not only should be accurate but it also should be reliable. So this process involves what? It involves removing the noise or reduction the noise, adjusting its brightness and contrast, and also correction of the distortion in the images. So after pre-processing, then comes the feature extraction. So in this process, in this step, what happens? It involves detecting the pattern or the feature of the image, of an image, and this features like shape, the texture of the image, uh, or the color distribution. So which enables the model to obtain the valuable data and information for sorting and displaying it. After feature extraction, then comes the next step, that is object categorization. Once the pattern has been recognized, the features has been extracted. So here, model can identify a new image that is provided to it by comparing with the features that uh, it has found while learning during this training. So based on the comparison, the system classifies the object into specific category. For example, suppose an image is given to the model, it can identify, it can categorize that either the image is of a cat or a dog or anything else. Next come the step is object identification. So here the machine it detects and identifies the specific object in an image, also find their location. For example, in a street image, the system can find a car, a person, or a traffic signal, and then it can draw the boxes around each of the image to show where it is exactly placed. That is object identification. Next comes, or the last one is the object tracking. Now there, suppose it's a video sequence. Now object can be tracked to the entire sequence by following the object. So in the entire video frames or the entire video sequence, the tracking of the object can be done. The system tracks the object in each frame, and that preserves their identity over the entire sequence under the challenging situation like the light or motion. For example, a CCTV camera. In CCTV camera, when it is trying to detect a car that is moving across, okay, so the system keep a track of the specific car that moves across different frames from the start and the end of the video. So that is object tracking. So these are the following few steps or the main steps that computer vision actually has or actually involves, has to follow. So first is the image acquisition, is collecting of the data, collecting of the images from the various sources like camera, like sensors, like a storage from the storage stored data. Then processing it, pre-processing like removing the noise reduction, adjustment of the brightness and contrast, also the color correction of the distortion. Then comes the feature extraction, then object categorization, like based on the extracted feature from the previous data. If new image is given to the machine, it can categorize that if the image is of a dog or a cat or anything else. Then comes the object identification, or detect and locate the image. Suppose a street image where you can detect a car or a pedestrian or the traffic signal where it is placed, and the draw boxes around those particular objects to specify its exact location. And finally comes to the object tracking. This tracks the object with the entire video frames, okay, from the beginning to the end. Next comes is the application of computer vision. These are the various applications. As we all know, the computer vision is extensively used in facial recognition system because of its ability to find the pattern in the elements in the data. Next comes the self-driven vehicles, where the computer vision enables autonomous vehicles to gain the sense of their surroundings by creating the 3D maps. Cameras capture video from the different angles of the car to find different objects around the car, like to identify the extremities of the road, browse traffic signs, or to discover alternative car objects or pedestrians. And accordingly, the car can move and approach on the streets and highways to avoid obstacles, and finally driving its passenger to the destination. Next come the healthcare. In healthcare application, professionals, the doctors can make better decisions related to the patient care. Even medical imaging analysis in one such procedure, it creates visualization of specific organs or the tissues to enable more accurate diagnosis. That means it helps the doctor to identify accurately what kind of disease the patient is having, or what is the condition of a particular organ or the tissues, to make a more accurate diagnosis. Next is the augmented reality, where, for example, say a smartphone is able to, the lens of the smartphone is able to detect a real life object, and it helps to measure the height of that particular, for example, height of a table. Rather than measuring it manually, we can take the help of a smartphone to measure the height of the table, the smartphone camera, to measure the height of the table by using augmented reality. Next comes super resolution. That is, it enhances the resolution of the images. Suppose there is some numerous low quality images, so it will interpret those and it gives such treatment to those images, like each and every image will have a unique information, and once the variation between the photographs are analyzed, then the model produces a stream of images of a significantly higher quality. And last comes optical character recognition, where the OCR extracts text from the images or the scanned documents and image only PDFs. It identifies letters, put them into words and sentences. The text is read using various contouring and thresholding techniques. Libraries like OpenCV are commonly used. So OCR is widely used to digitize text, scan passports for automatic check-in, evaluate customer data, etc. So these are the few various application of computer vision in our day-to-day life. So now here some of the everyday examples. For example, if you want to unlock your phone with the help of the face recognition, you have given your the image of your, so your mobile will scan your face and it will match with the image given to it, and then it will unlock your phone. So next is autonomous vehicles, I already told you before. Then medical imaging, that's ultrasounds to check the health of unborn babies, even other kind of medical imaging also. And photo organization, application that automatically label people and object in photos for easy searching. So these are the everyday examples of computer vision you will find in your daily life. So I hope students you have understood, or you have got a clear picture of what is computer vision, how it works, what are the application of computer vision. I hope my video will help you in this, will be helpful to you in understanding computer vision. So do leave your comments and reaction in the comment box. Thank you for watching, and stay connected with Learning is Fun by MGB for more videos in upcoming days. Thank you once again. Bye bye.